Alright, in this video I'm going to talk about horizontal asymptotes. So I have another video about vertical asymptotes, and remember vertical asymptotes are basically the value of x that we can't have in the function because it'll make the function undefined. A horizontal asymptote is what the function will never equal. So no matter what value we plug in for x, it will never be this value at the horizontal asymptote. So if we have a function like f of x equals, let's say 4x plus 3 divided by x. Okay, so just to illustrate the idea of a horizontal asymptote, let's plug in some numbers for our f of x. So let's plug in, let's start by plugging in 0. That'll give us, oh, we can't do 0 because that's going to make it undefined. So let's try 1. That's going to give us 7 over 1, which is just 7. We plug in, let's plug in 5. That's going to give us 23 over 5. And just so we have an idea what that is, that's, let's see, 4 3/5, or 4.6. Let's plug in f of 10. That's going to give us 43 over 10, which is 4 3/10, or 4.3. F of 15 is going to give us, let's see, 15 times 4 is 60, so 63 over 15, and that's going to be 4 3/15, which is, let's see, I'm going to have to use my calculator to get this in decimal form. That's going to be 4.2. And just for good measure, let's do f of 20. So that's 83 over 20. So that's going to be 4 3/20. So I'm going to have to use my calculator to get that as well. 4.15. So here I pretty much went up by 5s, with the exception of between 1 and 5 is actually 4. But I went up by 5s for the most part, and you'll notice that the difference between these numbers each time is getting smaller and smaller. So basically what we're going to see is the bigger that x gets, the closer we're going to get to 4, exactly 4.00000. But we're never actually going to be at exactly 4. And that's because we're always going to have this plus 3 here. So we have 4x over x, basically, but then we also have this plus 3 up here. So it's never going to be exactly 4. So that means that our horizontal asymptote is at y equals 4. And that means that our function is never going to equal 4. And if you think about it in terms of the graph is never going to cross or touch the line y equals 4. So that's one way to find your horizontal asymptote. You can also, if your degree is the same on top as it is on bottom, so if we think about the numerator, the part on top, as a polynomial, which it is, the degree of this polynomial on top is 1 because the highest exponent on the x is 1. And then the degree of the polynomial on bottom is also 1. So when we have the same degree on top and bottom, we can just take the leading terms and divide them. And the leading term means the term with the highest exponent, right? So here it's our 4x and our x. And I'll give you some more examples so that you know more what I mean there. But that's another way we can find the horizontal asymptote. And then another way is, and this is important because you might see this on the test, is a function might be written in a different form. So this is that same function from above. But this is equal to, basically we can split up the numerator and say this is equal to 4x over x plus 3 over x. 4x over x is just 4, so that's 4 plus 3 over x. So you'll see here, now we just have a 4 here. That's our horizontal asymptote. So if you have a function in this form where you have a constant plus some kind of rational expression, your horizontal asymptote is this constant here. I'll give you another example. If we have like g of x equals, let's do 6x let's do a higher degree. 6x squared plus 4x plus 5 divided by 2x squared. And we can actually split that into 6x squared over 2x squared, and then plus, and then I'm just going to keep the 4x and the plus 5 together, because I know that's not really going to simplify, but this will. So the 6x squared over 2x squared is going to give us just 3, plus 4x plus 5 over 2x squared. So this 3 right here is going to be our horizontal asymptote. So you might just see a function written in this form on the test, and you'll have to know that this constant is the horizontal asymptote. So let's do some more examples.